Hello everyone, I am Manav and in this video we are going to learn about the power, work and energy. Yes, about the power, work and energy. And we also take a closer look on the law of conservation of the energy and about some types of force or basic of the force. Okay, and also some formulas to solve the numericals on the work, power and energy. Okay, now today's topic. So let's begin with force. Okay, what is a force? A force means like we say push and pull. See, push and pull. This is we know that force. Okay, and this is our force. So work is everywhere. Okay, I am writing here is a work. Okay, I'm learning. Okay, I'm reading a book. These all things are the work. But it is so different from the physics, from a science. Okay, from the world of the science. Okay, so what we say, what is the definition of the work in the physics? What is that? We say that is that when there is a force. For example, I'm having a duster this, and I'm moving. I've done a work on this duster. Yes, on this duster. See, like this. Okay, so there is a displacement, and I have also do some work. I have done some work, and I give some force to it. So we say that work is equals to force multiplied by displacement. Means there is a displacement. See, this is a stationary duster. Okay, and this is here at a place. This is not here. Okay, and it is on that. So when I do like this, so it come here. It changes it. It displaces from it. Okay, from its area. And I have also give some force to this duster. So I have done some work. Yes, a work. So for example, I have give it to 5 Newton force. Okay, Newton is the SI unit of force. Okay, so I have give 5 Newton of force. And displacement, there is we say 15 centimeter of displacement. So what I have done work? What is the work on? Let's find it out. Let's use our formula of the work. So our newtons, 5 Newton, and multiply by 15 centimeter. So I've got 75. So it means 75 is I have done work on this duster, on this stationary duster. But this is not complete. Yes, this is not complete. How? Because I have not used this SI unit. What is the SI unit of the work? Our SI unit of work is joule. Okay, joule. We say it's like this. Joule. And if there's a statement that I have done 15 joule of work, and I don't know how much Newton I have used, how much Newton force I have used. Okay, but there is displacement of 5. Okay, 5 meter. So what will be our force? Okay, so let's find. So let's walk. Oh. Newton. Okay, so we will do divide. Okay, so see, this is our 15 over 5. Okay, the 15 is our work that I had done, and 5 is our displacement. 5 meter is our displacement. So we get 3 Newton that we have worked 3 Newton. Okay, so let's solve another numerical. Like if I having a very giant, huge rock. Okay, so it is too heavy. So how to find out that work? If I have do like this, I have pushed it, and I have used 29 newtons, 29 newton of force. Okay, spanned on it like this, pushing it like this. Okay, and there is displacement of only 5 meter. So what we will do? Multiplication, yes. So 25 joule multiplied by 5 is equals to 125. And what is our SI unit of our work? Yes, you are right. Joule. Don't write joule. We can only use the symbol J. Okay, to describe that there is joule. So after the work, there's energy. What is the meaning of energy? Energy means there's a capacity of any person having a capacity to do any work, okay? To do 50 joule work, okay? To do 10 joule work, etc. Okay? Having the capacity to move any object from its place by through force, by applying the force. Okay, so we have many types of energy like potential energy, kinetic energy. So in this video, we will only take a look on the formulas of our kinetic energy and the potential energy. So let's begin with potential energy. Let's understand some basic of the potential energy. Potential energy means that there is an object at a height, having a block. Having a block like this, okay, in my hand, for example, like this, having this. So there is some potential energy that is stored here. And when I do like this is the potential energy, okay? So this box will fall like this. So when it's falling, when it's here, so it is a potential energy that is on the height or while compressing anything, you know that. And after that, what is the meaning of kinetic energy? Oh, wait a second. What is the meaning of kinetic energy? We know that, right? So that is when an object is moving like this. Okay, and anything is moving like this. Okay, there is a kinetic energy that is stored here. So what is the formula to find out potential energy? Potential energy formula is mgh. Don't be scared from the formula, okay? M mean mass. I have taken an example in this video only. Okay, while studying this concept of energies, that is having any rock. We say its mass is 20 kg. Okay, this mass. We need this mass to find out the potential energy. And what is this G? It is gram? Oh no, it's not right. Yeah, this is the G. Wait a second. I will tell you. So here G is gravity. Gravity, okay, gravity, not gravitation. Gravity. Okay, so gravity. Why there is gravity? Why we have taken gravity? It is due to because when any object is at a height, so it is working against which force? There is any force, okay, in our earth. What is that? That is gravity, okay? So we will use gravity, not say it's gravitation, because gravitation is the force that is in the space in the universe. But gravity means that is there on the earth, the force that is on the earth. Okay, this falling is due to gravity, not due to gravitation. And let's do some numericals on the potential energy. For example, there's a duster of 20 gram. This is a duster I having a 20 gram, and I have taken it to the height of 4 meters. Okay, 4 meters or up like this. So and there is gravitation is we say 28. 28 is our gravity. So how to find out the potential potential energy that is here. When I have taken this duster, this 20-gram duster. So let's find out what we will do. Is our 20 grams, and our G is our 28, and height is our, we say, yes, what is the height? I forget. What is that? Yes, 5 meters. So we will multiply that all. Okay. So what we will get? Okay. So this is our 560, but it's not the potential energy. Okay. We need to multiply it by height, and our height is 5 here. 065 checking. 2800 is the potential energy in this case, that when a duster of 20 gram is placed on a height of the 5 meter and gravitation is 28. Okay, so we get 2800. Okay, wait a second, yes, it's right. Okay, so this answer is we get. So there is any SI unit of energy? Yes, of course. What is that? That is like exactly same to the our energy. Yes, our energy, or not energy, work. So what is the SI unit of our work? Remember. You forget. Wait a second. Is joule. Is the SI unit of work and also the SI unit of energy. Okay. And there are some conservation of the energy. What do you mean by conservation of energy? I mean the energy is changed after time or after a medium, after changing into medium. Okay. There's change in the energy if there's at the height there is potential energy, but at when it comes down, so to get kinetic energy, okay, and heat energy, we say like this. I'm clapping. This is our heat energy because there's a heat that is generating here. Okay, we know light energy. Okay? This conservation mean and change of the energy with the when it's change in the medium. Okay. It is on height or it is on the floor like this. So what is that? So for example of the conservation of our conservation of energy is like see, this is a toy. Okay, that the kids play with this. There's a car, we do like this, and the car moves and comes like this and then moves like this. So let's check. There's a conservation of energy in this all toy. Okay. So what is that? Wait a second. So what is that? Or that is that when the car is here. There's any energy? Yes, it is moving. Okay, it is moving. So which energy is this? Yes, you are right. This is kinetic energy. So when it comes here, and there, at this point or this point, this point, oh, this. Okay, like here. So there's any change of this conservation of energy? Yes. There's a change because when it is touched to the floor and it is in motion, so it is kinetic energy. There is no height, but when we come to this circle, there's an energy. Okay, there's a conservation of energy. What is that? Yes, that we have studied in this video. That is our potential energy. Okay, why potential energy? Because the car is here and any vehicle is here. Okay, so see that there is a height. There is a height. We can say that there is a plane that is made here. Let's roll like this. So there is a height than this roll. So when there is a height, we know that there is potential energy. And when it again comes here, so we know it changes to potential energy to the kinetic energy. Okay, so there's an example of the conservation of energy, and we are having another example that is also based on our the conservation of energy, but only two energy, which is our potential energy and the kinetic energy. I'm not saying that the conservation of energies only happens in both the kinetic and potential energy. There is also the heat energy, light energy. Okay, so yes, wait a second, let's complete that toy. Oh, wait a second. Like this. So if there's a block that I placed at this end. So when my car comes here and it hits to this block, this plastic block, so there's any energy? Yes, there's when it come like this. See, wait a second. When anything is attract like this, see, there's a sound. Okay, there's a sound. See, or okay, wait a second. You can see that there's a sound when two things are collapsed. So there's also sound when a car collapsed. Okay, but there's another energy. Okay, at this time, which another energy? There's energy when we are clapping. It is really related to the resistance or the heating effect. Yes, heat energy. Why heat energy? I have already told you that in electricity videos that when the charges collapse, there's due to the resistance. Okay, there is a heat. Okay, the heating effect of the electricity. So if I am doing clapping, see my hands are collapsing with each other. So there is a little bit, or not too little bit heat energy. So when the car is collapsed, so also there is a heat energy. Okay. Then another example of the potential and kinetic energy, the conservation of these both energies are the falls. Okay, waterfalls. Okay, this is a mountain and the waterfalls, water is falling. And this water is falling down. So see, this is our ground. This is our ground, means this is not at height, but this mountain where the this fall is begins. Okay, so there is we say there is an energy. Okay, it is on the height. So we know that which energy is this. You are now expert in the energies. That is our potential energy. Yes, our potential energy, because it is on height. We all know. But when it comes down, there is no height. So we can say that there is zero energy. Okay, there is no kinetic energy, no potential energy. That's wrong. When it comes down, we know that there is no potential energy, but it starts moving like this, like this. So when it's moved, we know when any object is moving, it is in a motion. So there is the energy. What is that energy? Yes, kinetic energy. Okay, so there is kinetic energy. Okay. Oh, I will not tell you the formula of the kinetic energy. Okay, so that is our 1 over 2 multiplied by mass over velocity, but not velocity, the square of velocity. Okay, so that, for example, there's a car that is moving like this. Okay, and the mass of the car is we say that mass of the car is approximately about we say 20,000 kg. Okay, it's two, so we say it's a truck. Okay, it's a truck. So its weight its mass is 20,000 kilogram, and its velocity is 20 kilometer to north. Okay, to north. So we need to find out the square root, square of the of our velocity. So the square of the velocity will be, we know to find out the square. We will do like this: 1 over 2 multiplied by what is our mass? Yes, 20,000. After that, yes, 20 km to 20 km. Okay, 20. So it will be cut out by the 2, and it will become 10. See, okay, it becomes 10. So now after that, this is our 1 over 1. So it is gone. So now we will multiply this only. So that is our 2, 0, 0, 0, 0 and 0. This 0 I have added of this 10. Okay, I have multiplied the 10. Okay, to the this mass of the truck, and now we get this. Now we will multiply to the 20. Okay, I'm saying 2. Oh, I have, wait a second. Oh, no. Fine. That's fine. Yes, it's right. So we said it's 200,000. Okay. So yeah, we say 2 lakhs. Okay, for the simplification, we say 2 lakh. So now we will multiply to the 2. I'm again saying 2 again. Okay, not to 20. This 20. Okay, right. It is 4 crore. Okay, so it is 2, so we will break it out, and we get it is at 2 or 4 crore. Okay, you can also try it. Oh, wait a second. So after the energy, that is a power. What is the meaning of power? Okay, power means like the rate of the work done. Okay, that work is going on. I have done the work. The capacity, not capacity. The rate. That the rate is. Okay, rate. The rate of doing any work is known as a power. Okay, there is a power in our AC. Okay, how much load they can take. Okay, to spend 10 hours. Okay, how much time they take. Okay, like this. So So power is also related to the work. Although this we say, although all these topics are different, they are related to the work. Okay, our energy is also related to the work, and this power is also related to the work. Okay, so our power. So power is like that the rate of doing work. So the formula of power is equals to work over T. W over T. Hey, what is the meaning of T? We know that it is time, and we know it is a work. Okay. So this is the formula of the power. If you have done the work of 50 newtons in the time of 10 seconds, so what will be our work or not power? How much power you have? Let's find it out. So we will use our formula. Yes, you have spent 50 newtons, and how much time you have taken? 10 seconds is equals to 5. We get 5. But there is the missing in the answer. What thing is missing? That is our SI unit. What is the unit of the power? It is joule, isn't it? No. It's SI unit. The SI unit of power is volt. The symbol of volt is W. Okay, we can use that W. Or if my power is 20 watts, and I have taken time of we say what time? We said that yes. I have taken 8 seconds, and I have worked. How much work I have done? How to find this? Oh, not like this. This is not a question, okay? So, numericals and some questions on the work, power, and energies are completed. Okay, so our today's topic is completed. Okay, friends? So, thank you.